what we're doing in 10.3, it's actually not that it's super hard, it's just it's different. It is way different. So what's happening is we are going to be looking at parabolas, graphing a parabola in a totally different way than we normally do. It is really different. So normally when we graph, if I was to say to you graph a quadratic, we do it by, like, look at this pink quadratic here. We do it with an axis of symmetry, right, and a vertex, an axis of symmetry, and then we have other points, right, everybody? So it's just we're going to have a new way of looking at a quadratic with a directrix and focus. So we're going to just be graphing quadratics using its directrix and focus. So it says right here, a parabola, that pink parabola, will be a set of a bunch of points, unlimited points on the pink parabola, where the distance will be the same from the focus and directrix at that point. So basically, let me show you what this is saying here. I'm going to go to a color, just so you understand what's happening. So watching, you just need to be watching. What this says is if we have a parabola, there's going to be a point, which is called the focus, and then a directrix, a line straight down from that, where from each point of the parabola, it'll be equidistant. So look at this point, that distance to the focus will be the same distance that it will be from that point to the directrix. Like that line and that line are equidistant. So and it's supposedly, I mean, it's true, like you can draw that anywhere and it will be the equidistant. So keep in mind, I rough sketched this by hand, and so it's not going to look perfect by me rough sketching it. But like, so from the focus to the point here will be the same distance from here to here. So it doesn't look like it because I didn't draw a perfect quadratic. But supposedly those distances will be equal. Does that make sense? The point of the focus to the parabola will be the same as the parabola to the directrix. Any point, so I could draw anywhere. From here to here will be the same distance as from here to here. Alright, so with that being said, that's what we're going to use focus and directrix to graph parabolas. Now, what I want you to notice is the directrix is a straight line, and the focus is an XY point. That's always going to happen. The focus will be some XY point, and our directrix will be some straight line at some value. So start writing this down, take a picture, you got to do it quick. So we're going to look at parabolas that are smiley faces and frowny faces first. So we're going to first just look at non-shifted parabolas. Parabolas with a vertex at 0, 0. So vertex 0, 0 means there's no shift left and right, no shift up and down for the vertex. And the equation that's creating this quadratic is x squared equals 4ay. All of our quadratics are going to have the form x squared equals 4ay for looking at it with a focus and directrix. Now looking at x squared equals 4ay, if you think about it, so as you're writing it down, let me let you write it down, and then I'm going to explain something, because you have to be able to see this equation and know that it's a smiley face parabola. So I'll explain that. It's an opening upwards. And then you have to be able to see this equation and know that it's a frowny face parabola. So write this information down that I'm... So here is x squared equals 4ay. Normally we graph things as y equals, correct? So if you think about it, if I was to, so 4a is just it's just going to be some constant. So if I was to get y alone, I would divide by 4a to both sides, and that would just create a quadratic that's positive. So positive quadratics smile, correct? So it's a smiley faced quadratic. The focus will always be inside the u. So we have some xy point right here inside our u. The directrix will always be directly down from that. Now we just talked about that they're going to be equidistant. That distance will be the same as that distance, correct, everybody? By definition, that's what a focus and directrix is. So let's look here. If I know the focus, now look, we know how xy points. Here's the x-axis, here's the y-axis. Isn't it true that this focus point is over 0, but up some amount? Up some amount. So that point is over 0, up some amount a. The focus is over 0, up some amount a. Now, if that's true, the directrix will be straight down. It's going to be just opposite of that. Do you guys see how it's a? This will be negative a, because look, it's down in the negative now. Do you guys see? Since that's up a distance of a, this will be down a distance of a right here. So now that's going to be down at y equals negative a. Now look, y was a, y equals negative a are opposites. That's how it's always going to work. So now looking at this next piece here, so the back can see, we have x squared equals negative 4ay. Because of the negative, that's what flips it into a frown, upside down. The focus will always be inside the u. So there it is. So now look, my focus is over 0, down a. Do you agree? Down some amount from the origin. Over 0, down some amount. Well, if that's true, the directrix is going to be up at, the directrix is not a point, it's an equation. So it's a line. So our directrix will be at positive a, won't it? Y. So it all just works out. If you know one, you know the other. If you know the focus, you know the directrix. If you know the directrix, you know the focus. So the important thing is being able to recognize when you see x squared equals 4ay, it's an upward facing parabola. When you see x squared equals negative 4ay, it's a downward facing parabola. That's key. From this, that's all you have to know, because the rest all makes sense. Okay, so now we're also going to have, these are the last two equations, we're going to have sideways facing parabolas on their side. So it's going to have the equation y squared equals 4ax. You're writing that down. You have to be able to see y squared equals 4ax and know that it's a graph that looks like this. A quadratic on its side in the positive direction. Now if you think about it, it actually does make complete sense. If we were to graph y equals, wouldn't we square root both sides to get it to be y equals? When we take a square root, we need a plus or minus the square root. So then here's our plus the square root, here's our minus the square root. Do you see? So if we were to graph it y equals, it would be the plus and minus square root graph. Now look, the positive means it's opening in the positive direction. Now look, y squared equals negative 4ax is just opening in the negative direction. Now once again, the focus will always be inside the u, so now look at the point for the focus here. I'm going over some amount, and then up 0. That's why my focus is a0. I'm going over some amount, up 0 now. Well, if that's true, my directrix will be back here at this negative value, and it's going to be x. Look, x is a, so right here, x will be negative a, since they are equidistant. And then same here. If you, once again, being able to see a picture is key here. And then, so y squared equals negative 4ax. My focus, my graph opens this way. My focus will be inside my u. So if I was to get to that point from the origin, I'm going some negative a up 0. If that's true, then my directrix is going to be at x equals positive that amount a. So the key part is being able to see these equations and know which way the graph opens, and that's key, and that's really all you have to know. After that, it all just falls into place and makes complete sense. So what we have to do, when I say graph, you're going to see that the equations have this form. All you have to do is graph the directrix, the focus, the vertex, and then one other point, which you'll see it actually falls into place quite nicely and easily. So do you have this all written down? Do you need more time? Understand how these directrix and focuses work? Okay, so I'm telling you right now, that this focus, so if we see this upward smiley face parabola, this was the equation of x squared equals 4ay, correct? Okay, awesome. Now that's great, but now I'm telling you, the focus is over 0 up 3 units. If that's true, then what's the equation of the directrix? It's at negative 3, correct? Now it's a y, right? Look, y is 3, so right here it's y equals negative 3. Does everybody see? All right, let's answer this one. You see this frowning face parabola, so this must be the equation x squared equals negative 4ay. And if that's true, I'm telling you the directrix is up at positive 5. So what would my focus's xy point be at? 0, negative 5. True. Over 0, down 5 to get to that point. Very straightforward. Okay, same thing here. You would have to recognize, oh, this is a sideways parabola, which was the equation y equals 4ax, because it's positive, opening in the positive direction. If my directrix is at negative 3, what's the xy point for my focus? 3, 0. Good. And then same thing here. My equation for my directrix would be what? X equals positive 4. If it was negative 4, this is going to be x equals positive 4. And my equation here would have been y squared equals negative 4ax because it's opening in the negative direction. Okay, now write this one down. All I'm going to say is graph, and notice the reason we're learning it like this is because, look, it's the equation of y squared equals negative 12x. So it has this form. You're not going to be told it has this form. That's me giving you a side note. So you're going to only be given graph y squared equals negative 12x. And you're going to have to recognize that has this form. Y squared equals negative 4ax. Good point. So, but is it a sideways one or a down and up one? This is a sideways one, right, actually? So, we will definitely say, okay, I'm not going to graph it yet because I'm going to do an exact graph, but a rough sketch we know is going to look like this, correct? It's a y squared graph. That's not the x squared, that's not the parabola, that's a sideways one, and it's negative, making it go in the negative direction. Does everybody agree? All right, now by definition, if we went back and looked at our equations here, A is what the directrix is. That A is the directrix. See, look, let me go back, because I want to just make sure you understand that A is the directrix. Back to here. See how A's were the directrix, everybody? So A is our directrix. So you're going to say, okay, you're going to line things up, match them up, and we're going to go through and use algebra to find our directrix. Look, y squared and y squared match up. Do you guys see? X and X match up. So isn't it a true statement that negative 12 equals 4a? Isn't that what matches up? Yes, so write out your true statement. That's your first step, is to find the directrix. Negative 4a equals negative 12, everybody. Now from there, solve for a. Divide by negative 4. And you get a equals 3. Now we got to stop and pause for a second. So that's our directrix. Now you got to kind of take it with a grain of salt. That's actually a distance. Now is it truly positive 3 or is it negative 3? So you'd go back to your rough sketch of your picture of your graph. If it looks like this, won't our directrix be back here? Yes, right? That's always what the directrix looks like. So it is going to be at positive 3. So that would be the first thing we'll graph. We'll go over here and draw in our directrix. And just labeling your graph. So you're going to say, this is my D for directrix. Now, we know that this is, our vertex is at the origin. So if that's true, and this is at 3, what is our focus? Good. Our focus is at negative 3, 0. Do you agree? Because it's equidistant, everyone. So you write that out. Our focus is at negative 3 of 0, and then label it focus. Now remember, your parabola always opens up on the focus, and we already know the graph looks like this, but you can't just draw in a rough sketch from here. You need to do at least just one other point, exact point. So what you're going to do from there is you're almost done. You're going to make an XY chart. I only have to do 1 point. So what we're going to do is we're going to plug in values and get out some values. X, Y, X, Y. How do X, Y points work? So notice this one, our input is X, correct? So if we plugged in, now look, if it's opening this way, we need to plug in negative values. So so you could plug in negative 2. I thought you would have that one in mind for a reason. You could plug in negative 2. Now look, if I plug in negative 1, watch, I'm just going to show you for this one. If I plug in negative 1, then what will my true statement be? It'll be y squared equals 12. Well, now when I square root both sides, I'm going to get a decimal, which is fine, but I don't want to graph decimal, so I'm going to not use negative 1. If I plug in negative 2, won't that be a true statement of y squared equals 24? Still a decimal when I take the square root. Let's plug in negative 3. If I plug in negative 3, won't that be y squared equals 36? So now that will be a perfect square root. So if I square root both sides, I get y is equal to plus and minus, because when you're solving and you take a square root, you need a plus or minus 6. So we actually now have 2 more points. We have negative 3 of 6, and we also have negative 3 down 6. And this is a point on our graph of the vertex. Now, one thing a student pointed out to me, which actually makes sense, is they said last hour, if we always plug in the focus point, that's the part that's going to make it a perfect square. So do you see how -3 was what made it a perfect square? That actually does always work. So from now on, we'll just use that trick. So now look, connect the dots. It's just a really wide sideways parabola. So we graphed first, we found the directrix, we then put in the focus, we then have directrix, focus, and then find some other points. Not too bad, right? It'll get easier and easier, like each time. Let's do another one. Okay, so it is now y squared equals 8x. The first thing you do is do the rough sketch thing. You say, okay, this is a y squared graph, which is a sideways, and it's positive, so it's going to look like this. And now we'll line things up. You have to know without me telling you that it has the form y squared equals 4ax. Yes?
Wait, so if it's, when we're not given the form of it, how do we know that it's the positive equal, not negative one? Because if we times it by like a negative a, then that means it'll be positive.
Just always go with the straightforward one. So if it's positive, go with the positive one. If it's negative, go with the negative one. Good question. All right, so now let's solve A, because A is our directrix. That's our first step. So set up your true statement. Y squareds match up. X's match up. So it's the true statement is 4A equals 8. Therefore, A equals 2. But once again, take it with a grain of salt. You're going to say directrix is actually, it's not at positive 2. Isn't it at negative 2? Because of what the graph looks like. So you're going to say my directrix is actually at A equals negative 2. So now that would be the first thing I go draw in is my directrix at negative 2 and label it directrix. Well, if that's true, what will my focus be at what point? 2, 0, over 2, up 0. Does anybody, and then label focus.
So you plug in 8x for ax, right?
Plug in 8x for what?
For ax. Because you were drawing the line.
4a equals 8 is a true statement. Those are what line up. So then a equals 2.
And the x is then just
Well, x is x. It's just this, it has this form. So now from there, our vertex for this is at 0, 0. And then from there we need some more points. So you'll just make an XY chart here. And then let's plug in, we said 2, correct? Was our focus point? Yeah. So let's plug in a 2. But careful. Yeah, we are plugging it in for x. Input, output. So if I plug in 2, then this is my true statement. Y squared equals 16. So y is equal to plus and minus 4. So now we're going over 2, up 4. Over 2, down 4. And that's enough points to actually graph it. Focus, directrix, 2, couple other points. Okay, we're almost, so let's do this one. X squared equals 8y. So once again, the first step is to draw a rough sketch. This is an x squared graph, and it's positive. Won't it look like this? That's the first thing you have to know. Once again, it's not going to tell you it has this form. You're just going to have to recognize it. So now my true statement is 4a equals 8. Therefore, a equals 2. Taking the directrix with a grain of salt once again, because isn't it actually negative 2? So that would be the first thing I draw in, and I label it directrix. If that's true, my focus, picture where your focus will be, won't it be up that same distance? So up at positive 2. So that was at 0, over 0, up 2 units. Now from there, we just need a couple more points. So 0, 0 is obviously a point. And then we're going to make our XY chart. And I'm going to plug in a 2. But now careful, we're not plugging it in for X, are we? Look, isn't our input a Y? Input, output, correct? So we actually go to Y and say I'm plugging in a 2 for Y. Then that's my true statement is this. X squared equals 16. So X is equal to plus and minus 4. So positive 4, 2 and negative 4, 2. And there it is.
Where did you get 16 from?
Because if we take and plug 2 in for y, 8 times 2 is 16. So it's just a true statement after that, yeah. Different. Because we're really just plotting, we're just graphing a quadratic. It's just in a unique way. Okay. Another one. Last one for this non-shifted ones. Okay, so x squared equals negative 12y. You would recognize that it has the form x squared equals negative 4ay. Then you would draw a rough sketch. So this is a frowny-faced parabola. So then your true statement is negative 12 equals negative 4a. So a equals 3. But then you say, is it positive 3, directrix, or negative 3? It's up at positive 3, isn't it? So I go up to 3, draw in my directrix. Therefore, my focus is at over 0, negative 3. Then from there, changing colors, origin, and then plotting some XY points. Careful, because on this one, our inputs are Y's. Input, output. Input, output. Okay, so then plugging in a negative 3, correct? Because that's our focus. I didn't label it. That should be an F. Okay, plugging in negative 3. Uh-oh, put it in the wrong spot. It's on this side. Plugging in negative 3. So then my true statement would be x squared. Plugging in a negative 3 right there is x squared equals 36. So x is equal to plus and minus 6. So we go 6, negative 3. 6, negative 3. And then over negative 6, negative 3. It should always open up on your focus. So your graphs should always make sense because they should open up. Uh-oh, don't erase. Don't erase. There we go. So it's really not that bad as long as you follow those steps. It is different. Okay, let's go this way. So you might want to write this down. You do have to think a little bit, kind of drawing yourself a rough picture. It says, find the equation of the parabola with a vertex at 0, 0 and a focus at 5, 0. Find the equation. Now, because this is find the equation, you have your 4 equations as a basis to start. Does everybody understand that? So we have our this. X squared equals 4ay. We have our x squared equals negative 4ay, right? We have our y squared equals 4ax, and we have our y squared equals negative 4ax. So let's see which one it is. Let's draw ourselves a rough picture because then we know which one it is. Here's my xy chart. We're told our vertex is at 0, 0 of our parabola. The focus, changing colors, my focus is over 5 of 0. There's my focus. Well, then my directrix must be back here, correct? So it must be opening like this. Because it always opens up on the focus, inside the U. Does everyone see? So which graph was that? The y squared graph, right? Positive. So you'd say, okay, I'm starting with this equation. Y squared equals 4ax. Now all we have to get rid of is a. We have to know what a is, and then we're done. If we know what a is, then there's our equation. So a is the directrix. What is my directrix at? Negative 5, correct? So plug in negative 5 for a, since that's what it is. So we have y squared equals 4 times negative 5x. So my final answer is y squared equals negative 20x. There's the equation that created this graph. So basically we pick which one it is, we find a. Pick which one it is, find a. If you have your focus, way easy. Yes. They even sometimes give you the directrix. Then you just plug it in, right? Good point. But you would have to know which one it is. So drawing a rough picture. Let's do another one where they don't give you the focus or directrix. And let's see how to do it. Writing it down for yourself, it says find the equation. Just say equation, vertex, axis of symmetry at the y-axis, and the graph containing the point 4, 3. Drawing a rough picture is really going to help us here. Find the equation of the parabola with a vertex at 0, 0. Axis of symmetry is the y-axis and the graph containing these points. So you're saying if we draw an xy graph here, you're saying, okay, my vertex is a 0, 0, and it's the y-axis, so good point. Do you guys see why she's saying we know it's up or down? If that's the axis of symmetry, then it has to open up or down. It couldn't open sideways. So it's either up or down, so we know it's either x squared equals 4ay or x squared equals negative 4ay, right? We also have the point on the graph over 4 up 3. So we definitely know it's a smiley face. Otherwise, how's it going to go up there to connect to that point? Does everybody see? 4, 3 was another point on the graph, we were told. So we know it's this graph. Here's our basis. X squared equals 4ay. It's positive. So now from there, notice we don't know the focus. We don't know the directrix. Perfect. That's exactly what we're going to do. Way to think. So we're going to take and say, but we do know this xy point, so we can take and plug that in for x, take and plug that in for y, and then we can solve for a. Because that's your next step, solve for a, every time, which is the directrix. Okay, so here we go. So now you'd say, so 4 squared equals 4 times a times our y is 3. So my true statement is 16 equals 4 times 3 times a, so that's actually 16 equals 12a. So solve for a, so divide by 12. 16 over 12 equals a. So simplify that, we get 4/3. So a equals 4/3. So now we just go back to our general equation, plug in 4/3, right there. 4/3 times 4 is, we multiply straight across everybody, 16/3. So our answer is x squared equals, I did 4 times 4/3, that's how I got 16/3 y. Do you guys need more examples of that kind? You're sure? All good. Do you want to try one by, do you have these two you could try by yourself, or if you feel golden, we'll be done with that part. Do you want to try one by yourself? Okay, pick one, or pick the top, I don't know, pick whichever one you want. And have the bottom one. Anyone else get that?
I got y squared equals 4/3.
Anyone else get that? This one? Okay.
I got 4/3.
Awesome. All right, good. All right, now this is the last thing of the lesson here. It's actually decently quick. So now we got a shift. All of those had a vertex at 0, 0. So right here is the parent function we've just seen all those times. It's going to have that same form. It's just going to now have a shift and a shift. So shifts left and right are with x. Shifts up and down are with y. And because they're both in parentheses, we do go opposite. That'll just change your vertex. It'll just shift it all. It's literally just going to shift it all around. So once again, this will be your shift. This is our parent function. Look, it still has that same form. It's just now a shift and a shift. Shifts left and right go with x. Shifts up and down are with y. And we go opposite. So let me just show you. Let's look down here. It's all pretty straightforward. If I said to you, given this equation, do you guys see how you would say, well, if I said to you, what is the vertex here? So just a reminder, shifts left and right go with x, right? Could be -3 is not a shift of left 3. Shifts left and right go with x. Correct, everybody, for all functions. This is your shift up and down. And it's opposite because it's in parentheses. So up 2. So my vertex is -3, 2. Correct? My directrix will still work the same way. It is going to be a shifted directrix. So, but right here, isn't the true statement 4a? Isn't that normally 4ax, everybody? So 4a equals 4. Because that's just a shifted x. So that's still 4a. So 4a equals 4. So a equals 1. And then we would have to shift it, the same as these shifts. So our directrix would normally be at 1, but then it was shifted, and so on. And then our focus normally would be at what? Oh, we'd have to look at our graph, wouldn't we? Y squared, and it's positive, looks like this. So wouldn't my focus be at negative 1 up 0? It would be back here, wouldn't it? But then we would be shifted. That's the non-shifted focus and directrix. Alright, let's just focus on vertex for this. What would my vertex be at? 1, negative 5. Okay, good. Then right here, same thing, shifted x's. Just have that same as shifts. Shift left and right, shift up and down. Shift left and right, shift up and down. Because shifts left and right go with x. So what would my vertex be here? 3, 2. Then we'll go through and do directrix and focus later. My vertex here would be at negative 1, 3. And then it's basically just, we're going to find our normal focus and directrix and shift it. Oh, that is a y. That should be a y. Okay. Good point, good point. Okay, let's just start graphing these. So write this down. Graphing them is actually the easiest way I've found is honestly graphing the parent function and then just shifting it. I taught it differently first hour and it made it so much harder than it needed to be. So just graph the original parent function and then we'll just shift them all. It's going to be way easier that way, I just know it. Okay, so first of all, if you would look at this, you would say the parent function is this. Y squared equals 8x. That would be the parent function. Do you guys see? Taking off the shifts. Then you'd say that one has this form. The form is y squared equals 4ax. So the first step is to find the directrix, just like we've graphed all the others before. We're basically just going to graph the original, and then we'll shift them all. So isn't it true that 4a equals 8, therefore a equals 2? Now we have to know what the graph looks like. Isn't this a y squared graph and positive, so it must look like this? So my directrix is actually back at negative 2. So I'm going to go back at, right here is my original. So I'm going back at negative 2 and drawing in my directrix. This is for the parent function. Then from there, my focus for the parent function, this is all parent function stuff, the focus will be at over 0, over 2 up 0, won't it? Labeling it focus. Now at the parent function, it was at 0, 0. In a minute, we'll shift that. And then didn't we plug in x, y points? We're plugging it in to this parent function. So shouldn't we plug in our focus, which is 2? Plug it in for x. So you plug in 2, and our true statement is y squared equals 16. So plus or minus 4. So over 2 up 4, over 2 down 4. Now what I'm going to do is take all of those points and like even the directrix, the focus, and all those 3 points and just do the shift. So the shift is right 3, down 1. Does everybody agree? So now from here, take the directrix and shift it right 3 units. So won't that be at 1, 2, 3? Won't it be at 1? So here's my final graph. At 1 is my new directrix. That's not right.
Yeah. So it would be
Right. You guys see what I did? I switched it. So this is actually left 1, up 3. There we go. Okay, so we're actually taking this and going left 1. So let's redraw that in. Left 1, so it used to be at negative 2, now it's at negative 3. There's our new directrix. Take the focus. It used to be right here. We're shifting it left 1 and down, up 3. So left 1, up 1, 2, 3. So now it's at the point 1, 3. Do you see how I just took this point and did the shift? Do that with all of them. So now changing to red here. So So that was my new focus. And my Directrix points will just do the same thing. So they're shifting left 1, up 1, 2, 3. So that's over 1 up 7. My center at 0, 0 is now at -1, 3. So -1, 3. We're almost there. And then take this and go left 1, up 1, 2, 3. So that would be at 1, -1. And then it's just been shifted now. That really is so much easier than doing it the way I taught it first hour. Draw the original. It's just a pain in the butt. But it got confusing otherwise, kind of. Not bad, bad. What do you think? It's just kind of this. It's the same thing. Just yeah, and then you just shift it afterwards. Do you need another example, or do you think you're okay? You would just graph the original. Like, so what would my parent function be here? So x squared equals -16y. Graph that original, just like we've practiced 10 million times, and then just take all of it and shift it. Okay. Sweet! I think we should practice the last 15 minutes of class, practice some focus and Directrix. Okay, if it has this form, if this is graph, you would have to look at this and say, well, it's not a circle because it doesn't have a y squared, right? It's a parabola. So you're going to have to recognize it's an x squared, so it must be this form. So now if that's true, what you're going to do is you're going to leave it so that you have all your x's on one side and anything else on this side. So we have x squared minus 2x. I'm going to bring this over and this over. So equals, and then right now I have this, -8y minus 25, because I brought those over. Now we need to get this in factored form, because then that would be shifted form, so we complete the square. So -2 divided by 2 squared, which is -1 squared, which is 1. So I'm going to add 1 to both sides of the equation, just like we did with our circle. So now on this side, that factors to be x minus 1 squared. Do you guys see how it's the same as the circle thing? And then is equal to, and then on this side I have -8y, and then I have minus 24. Now look how close we are to getting it in the right form. We just need it to be a shifted y and just a constant in front. This always has a constant. So now looking at this side, we're not completing the square, it's not a quadratic, but what can we factor out? A -8, right? To make it just y. So now we would factor out a -8, and then divide by -8, divide by -8, so then left would be y plus 3. So now look, we have it in our shifted form. X squared equals -4ay. There's our shifted form. So now we would graph it like normal. Wouldn't we just graph x squared equals -8y? Remember how we graphed that? And then we just shifted it all. You guys are kind of looking confused. Do you want to do another one? Okay, let's look at this one. So this one's a y squared graph. So get everything with a y on one side and everything else on the other side. Then you'd have this, y squared minus 4y equals, adding those over, 12x plus 32. Now from here we need it in factored form, so we would complete this square. B divided by 2 squared. -2 squared is 4, so we add 4 to both sides. Now factoring this side, that will factor to be y minus 2 squared equals, and now on this side I have 12x plus 36. To get it in the correct form, we would factor out the 12. So we have y minus 2 squared equals, pulling out a 12, divide by 12, divide by 12, then left is x plus 3. And now it's in the shifted form. So the parent function would be y squared equals 12x. Do you guys see? Then from there graph it. Then from there shift it.
So once we shifted it, do you want us to reset our focus?
Didn't think